So we've looked at how we calculate the area under a curve using integration between a set of limits. So from a to b, how we calculate that area, but it's always been for when it's above the x-axis. How does it change when it's below? How does it change when we're calculating an area where the part of the curve we're calculating is below the x-axis? So what I mean is something like this. Imagine I want to calculate the area of the curve x squared minus 6x plus 8 between 2 and 4. So I want to calculate the area of this part of the curve here. Now we say area and it's a curve, so it's between the axis and the curve. Instantly we still have to think about integration. So I still want the integral. Now because it's a definite integral, I know my two limits. It's the integral from 2 to 4 of this, of my original function. So it's the integral from 2 to 4 of x squared minus 6x plus 8 with respect to x dx. So I calculate the integral, substitute in my limits, and I should be able to get the area. So if I integrate it, I get x cubed over 3 take away 6x squared over 2 plus 8x. And again, it's between 2 and 4. So it's between those limits there. Plug in the limits, upper take away the lower, and I'll get my area. So I've got 4 cubed over 3 take away 6 times 4 squared over 2 plus 8 times 4. That's in one bracket. That's then take away my second bracket, so my lower limit, 2 cubed over 3 minus 6 times 2 squared over 2 plus 8 times 2. So do this first one. 4 cubed, well 4 fours is 16. 4 times 16 is 64, so it's 64 over 3. Take away, well this 4 squared is 16. 6 divided by 2 is 3. So 3 16s are 48. Plus 8 times 4, well, 8 fours are 32. That's the upper limit. So then take away the lower, 2 cubed over 3, so that gives me 8 over 3 there. Take away 3 times 2 squared, which is 12, plus 16. So now it's a case of simplifying both brackets and getting a final answer. So this one here, stick it all over a common denominator. So I've got 64, take away 144, plus 96, all over 3. It's then take away the second bracket, so I've got 8 minus 36 plus 48 over 3. Simplify both and then you get your final answer. So 64 take away 144, that gives me negative 80, plus 96, that gives me 16 over 3. It's then take away 8 minus 36 plus 48, well 48 take away 36 is 12, plus the 8 is 20. It's 20 over 3. Now you notice something here. 16 over 3 take away 20 over 3 gives me negative 4 thirds. So I've just calculated the area underneath that curve and it's given me a negative value. But you can't have a negative area. You can't have a negative size of an area. So what do we do here? How the heck has that happened? Well, what this means is for this area, that's the size of it is negative 4 thirds. So to convert it into an area, I need to ignore the negative sign. So my area in this case would be 4 thirds units squared. So 4 thirds in terms of whatever units it is they give you for the question. So this is a key thing. When we have a negative set of units, so when we do the area under a curve, we'll get a negative area. But in order to put that back into the appropriate context, we have to ignore this negative sign and take it as a positive value. Just remember that you can't have a negative area. So using this idea and this property, what we are able to do is generalize a way in which we can calculate the area of any curve that has parts above the axis and parts below the x-axis. So something that looks like this. If I've got a function y equals f of x, and it's a curve that looks in this way, and I want the area from a to b, so I want to know the integral from a to b to give me the area of f of x dx. Well, I've got to remember, this will give me positive, which is great, but this part here will give me negative. So what I have to do is find the roots, i.e. the places where it cuts the x-axis, and use them to my advantage. So if I name this root here in the middle C, I would need to do the integral of this first part and the integral of this second part and then combine them. So to get the integral from a to b, I'd have to do the integral from a to c, so the part above the axis, f of x dx. I would then have to take away the integral from c to b of f of x dx. Now I know I just said add it, but think about it. If I take away this area, this is a negative. So it'll then become minus minus, which becomes a plus. Another way you could think about it is if you want to put an add in the middle, it just works better with your brain, add the magnitude of this. This is how we have to do it. Now this can occur in many ways, i.e. it can occur for any number of above and below the x-axis sections. So I could have a curve that looks something like that, and I want the area from here to here. I would have to do 4 integrals. I'd have to do one for this section, one for this one for this one, and one for this one, and add them all up. So you just break it down into little sections that are above the axis, below the axis, do your integral from the various limits, and then combine the whole spiel together in one calculation at the end. Let me show you what I mean. I want to calculate the area between negative 4 and 2 of the curve y equals 6 minus x squared. Now this curve here is going to be a quadratic that loops up the way. In order to do this, first thing you should do is find the roots. So factorize this, and what you end up getting is you get 3 plus x 2 minus x. And that gives you roots at x equals negative 3 and 2. So if I were to sketch this curve here, I'd have roots at negative 3 here, and I'd have a root at 2. Now, I know that this is curving up the way because it's a negative x squared. So I know the curve is going to look something like that. And I know the lower limit for my integral is there, so it's at negative 4. Now this is a rough sketch. This doesn't have to be exact at this point. This is just you interpreting the situation scenario to make it easier for you to look at. So I've got a bit below and a bit above. So what I'm going to have to do is the integral of this part here and the integral of this part here, and then combine them. So what I'm going to have to do is the integral from negative 4 to negative 3 of the curve, and then the integral from negative 3 to 2 of the curve, and then put them together. So negative 4 to negative 3 is 6 minus x squared dx. Integrate this part here, and you get 6x minus x squared over 2 minus x cubed over 3. And that's from negative 4 to negative 3. So we substitute in our limits and we work it through. So I get 6 times negative 3, take away negative 3 squared over 2, take away negative 3 cubed over 3, so that's the upper part, then take away the lower part, 6 times negative 4 minus negative 4 squared over 2, take away negative 4 cubed over 3. So I've got my two brackets and my two parts. It's now just a case of combining them. So this one here, 6 times negative 3 gives me negative 18. Take away negative 3 squared, well, negative 3 squared is 9. So it's then take away 9 over 2. There's no change in sign there. But then it's take away negative 3 cubed over 3. Negative 3 cubed is negative 27 divided by 3 is negative 9. So minus minus becomes a plus. So it's plus 9 there. Then take away, and it's the same sort of deal here. 6 times negative 4 gives me negative 24. Negative 4 squared is 16. Divided by 2 is 8. So it's then negative 24 take away 8. Then negative 4 cubed gives me negative 64. But it's minus minus, so that then becomes plus 64 over 3. Sort each of the two brackets out on their own. That gives me negative 27 over 2 for the first bracket. It's then take away negative 32 over 3. So minus minus becomes a plus there, and when I combine them, I end up getting negative 16 over 6. So that's my answer for my integral there. I then do the integral from negative 3 to 2 of the same function. So 6 minus x squared dx. Now integrating it gets you the same general function. So I end up getting 6x minus x squared over 2 minus x cubed over 3. But this time, my limits change. So now it's from negative 3 to 2. So I calculate this new bit and then I can combine my two answers. So this gives me 6 times 2, take away 2 squared over 2, take away 2 cubed over 3, minus 6 times negative 3, take away negative 3 squared over 2, take away negative 3 cubed over 3. Now 6 times 2 is 12, so I've got 12. 2 squared over 2 is take away 2, 2 cubed over 3, take away 8 over 3. And it's take away the second bracket here, but the second bracket ends up giving me the same as the first bracket here, which was negative 27 over 2. It's negative 27 over 2 here. So the first bracket, 12 minus 2, that's 10. Then 10, take away 8 over 3. Well, 10 is the same as 30 over 3. 30 minus 8 over 3. That gives me 22 over 3. Minus minus becomes a plus 27 over 2. Calculate that, 22 over 3 plus 27 over 2. That ends up giving you 125 over 6. So that's the area of this section here. Now I've got to combine the two of them. So now I have to say the total area is equal to the 125 over 6 plus this area here, the 17 over 6. Remember, we ignore the negative and we add the two of them together. Add the two of those together and simplify as much as you can. You get 71 over 3 square units. When we're calculating the area like this, with a bit above and a bit below, this is the key thing we need to know. First, we figure out the roots so we can see where it crosses the axis, where this sign change is going to take. We can then use those roots to calculate the limits of our integral. Once we've got that, we know how many integrals we have to do, and we do each integral on its own, and then combine them at the end, ignoring the negatives. Once we do that, we get a final answer which indicates properly the total area covered by the graph.